You cannot go to any major semiconductor manufacturer today and find evaluation kits of theirs that do not have Arduino, Uno, and R3 headers.
I know, I like that. It pisses off a lot of people.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Dave Finch. Today in the lobby, I am joined by the legendary Massimo Banzi, co-founder and CTO of Arduino, to talk about technology, design thinking, and how to build something that lasts. As a young man from northern Italy, a haven for entrepreneurial spirit and design thinking, Massimo Banzi co-founded Arduino, one of the most accessible and popular open source platforms on the planet. From its humble beginnings in a technology classroom, the Arduino platform has launched countless engineering careers and even companies. Now, Arduino is poised to break out of its groove and enter the realm of large-scale commercial applications, including factory automation, smart agriculture, and even artificial intelligence. Massimo joins me now via Zoom from his home in Switzerland. You know, we're talking engineer to engineer, but we're also talking creative to creative. And one of the things that I've never done, and will probably never do in my entire lifetime, is transform an entire industry. And this is something you've managed to do.
Well, you know. Sometimes it's just about, it's being in the right moment, timing is one of the most important things, and you never know if you are in the right timing. It's just, in a way, there's a part of it is just pure being exactly in the moment where people need what you're trying to do.
Timing is critical for this sort of thing. But it's one variable that you cannot control. The thing that you were able to control, though, is seeing a clear need, having the ideas for how to address this need, and then having the courage and the vision and the conviction to proceed with the vision that you knew was right. And I think that's what's really unique here. What got you into engineering? Were you an engineer?
Yeah, well, I follow the path that a number of people follow. So as a kid, I used to take apart everything I could put my hands on. And then it started to get to the point that people would bring things to my house so that I could take them apart.
Wow.
Which was quite impressive. And I remember there was this crazy moment where a friend of my father, who had like an insurance agency, had like an old computer that was kind of like a weird mixture of a typewriter with like a computer attached to it. It was just an invoicing machine.
Yes.
So it took it to the house, and I just spent weeks taking it apart. And it was just amazing because there were like core memory. It was like a very, very old machine that he was going to throw away. So then after that, I guess my parents realized that I liked that kind of stuff. So they gave me this kit, which is a kit from this Braun, the German company in the 60s. They used to be the Apple of the time. All the consumer electronics, the cool consumer electronics was coming from Braun in Germany. And this was designed, the kind of the shape in a way was designed by Dieter Rams, which is the same designer that Apple has been getting a lot of inspiration from. So a lot of the designs that you see in Apple now, they come from, there's even a website where you see like Apple products on one side and Braun products on the 60s. And you can see
Really?
Yeah. Well, they took the inspiration. I mean, Dieter Rams is one of those people that inspired generations of designers.
He applies what we would call now design thinking. This is what he was doing back in the 60s.
Yeah, also one of the people that kind of codified some of this design thinking. There are these 10 rules of design by him that are very, very famous. But the interesting thing is that particular kit was such a great combination of like these little electronic components in magnetic blocks that you would snap together. You would build a circuit. There was a book where the electrons were little bubbles walking around. So the electricity was explained to kids in a way that was very understandable. I was 7 years old.
That's perfect.
I understood. And but I also got very interested in design, no? The very nice way this was kind of laid out, imagine how the objects were thought out was made me like appreciative of design.
So then you get a little bit older and you go to university and you're learning software engineering, hardware?
I actually didn't learn that in university. So I started to code when I was about 13 because I managed to save some money, and then I convinced my parents to get me the little black box. That's a Sinclair ZX81. I would connect that to the TV and just program it, and I learned how to program in BASIC with that. So when I went to university, I already knew how to program in a couple of languages. So I knew a bit of I knew Pascal.
Yep. Basic
and Pascal. Yeah. Because I managed to convince my father that if we bought this Apple II that was very old, that was in a window in a shop, if I could write some code to just invoice. He had a shop, so I could print invoices. But out of that, I learned how to program in UCSD Pascal.
Did your father love this? Because here he has a son who's saying, Dad, we don't have to run the shop with paper invoicing, and invest in this for me, and I can help you transform your shop.
Yeah, he's partially responsible because I guess at some point he had this hobby of electronics a little bit too. So he bought a bunch of magazines. So a lot of the electronics I know, I learned by opening the magazine when I was a kid and just read the article, not understanding anything, looking at the schematic diagram and say, hey, that's a transistor. I remember from my kit that that's a transistor. So I would read the description, try to understand, look at the schematic diagram, and I would basically learn a lot of electronics just by absorbing it, just by looking at a ton.
Wow.
There's a funny parallel. No? That there's a famous German director called Wim Wenders, and they said that his understanding of cinema comes from the fact that he spent basically years sitting in this Cinematheque Française watching movies. So I learned electronics by reading like 1,000 schematic diagrams when I was a kid. But this idea that you understand, you buy something, you assemble it, and then you must understand why that works. It's a process that I understand. That was my process. No? Learning by doing, learning by looking at other people, diagrams.
There's an interesting part of this. A lot of engineers and systems thinkers that I have known and worked with and been friends with, they sometimes lack the understanding that a user has to be able to sit down with their technology and make sense of it, and sometimes very quickly. Your appreciation for what you perceived as, here's a design and the building blocks are explained to me in a way that makes sense. And and this opens up a whole world. The point of technology is to improve our quality of life. And I don't think that there needs to be this insulation or this very high protective wall around technology that keeps people out.
Yeah. I guess I remember, when I was in high school, I did a few projects for people for money because, my family wasn't rich. So I had to kind of work. And so I did these projects where I would just buy these kits, solder them up, and then install them for people. Like example, there was this guy that had like a small factory. And when he was working on his lathe, the noise would be too much and he wouldn't hear the phone ringing. So I built this thing that would kind of flash a light on his lathe when the phone was ringing.
So now you're starting to see, even as a boy, that not only is the technology actually quite accessible if somebody frames it the right way, but if you're going to invent something or build something, it should really have a purpose.
Yeah. Yeah. Then, I started to build these things like, I remember I built this PCB that will allow you to, this is not very nice, but, the Commodore 64 used to have these special tape players. So I built this circuit that would allow you to connect two tape players together so you could copy the games. No,
Yes.
I know this is not very nice, but I was like 14. So I built this thing, and we got to the point that some people started to say, if they started to ask me if I could manufacture that in scale, and I was like, how do I know? What do I know? I'm 14. I just made one. But it was kind of interesting.
So you must have known that this was where you were going into adulthood, saying, I'm really good at this. I'm going to keep following this.
Yeah, in a way, it was kind of nice. I never really had to kind of guess what I was going to do.
Amazing. I still don't know what I want to do, and I'm 43. Hey everybody, it's Dave. This episode of Moore's Lobby is brought to you by CUI. CUI Inc., a Bell Group company, is here to deliver power when you need it. As a leading provider of AC to DC and DC to DC power supplies, they are dedicated to offering choice, reliability, and ease of access to their products and first-class service. The goal is to assist you during your design process and provide the right power supplies for your consumer, IoT, medical, and industrial designs. CUI Inc. products and resources can be found through their diverse distribution network or at CUI.com. All right, we are back with Arduino's Massimo Banzi, living legend, talking about how he was able to transform not only learning and prototyping as we know it, but also, to some extent, perhaps the entire industry of electronics. How does Arduino become Arduino? Is it something that you just developed for to solve one problem, and then it turns out there's a huge application for this?
Well, yeah, it's an interesting thing. So it's an interesting story, I guess, because if we fast forward a lot, I spent a lot of years doing web.
Yeah.
So, and out of that experience, I moved to different countries. And at some point, I ended up working in a venture capital fund, but I didn't really like it.
Mm-hmm.
And then a friend of mine told me, hey, there is this design school that just opened in the northwest of Italy. And they do this thing called interaction design, which is a combination of design in a way applied to digital technology. And they are looking at somebody that can help the student kind of prototype their ideas with electronics. And I was basically taking some kind of a sabbatical at the time. And I thought, I'll do this. I'm just totally doing this. So I went to this city called Ivrea, and I started to help the students. And I was supposed to be there for like 2 weeks, and I was there for 4 years.
This is near Milan, then?
Yeah, it's kind of a little bit west of Milan, near the French border. Ivrea was the place where this company called Olivetti was born. Olivetti was, still exists, but it used to be, they started making typewriters at the beginning of the century. They built all sorts of things. And then they also built PC. And at some point in the kind of early 80s, they were like huge. They were making a ton of PC. They were like the second manufacturer in the world at some point. They were even making PCs for AT&T in the US. In a way, Olivetti for a time was kind of the Apple of that world.
Yes.
Because they had the best designers in Italy doing the shape of all the products they built, and they had high-end products. They did a lot of work on culture. So anyway, so they used this building. There was the R&D building of Olivetti to set up this school. They got the director to come from the UK, professors from all over the world, and here I am, there, and I'm working with the students. The interesting thing, there was this idea that in interaction design, you build prototypes of any idea you have because your objective is to test them with people. Because that phase where you study how people use the thing that you just imagined, it's the next step. Because normally in the world of classic design, you make a mock-up, which is essentially sometimes was a piece of wood. Says, okay, this is the shape of this thing, but it doesn't tell you anything of how people would use it.
Right.
You know?
Right.
But the objective was to build functioning prototypes so that people could be exposed to them and you would study them. And from what you understand, you could feed it back into the design until you had it working. So my job was that. So I started to look at all the ways I could make the prototyping simple for people. And all these things I did when I was a kid and a teenager, they came back. Because suddenly, I realized the first day I started teaching, I started to teach like they taught me in school. So I was talking about the atom, the electrons, and people completely tuned out. And they started to browse the internet. And I was like, okay, this doesn't work. So the next day, I came back and I started to teach the way I learned as a kid. So I showed up with a bunch of potatoes and lemons and nails and LEDs. And I started to show them that if you put the nails into the apples and in the potatoes and the lemons, you can light up LEDs. And so we started to talk about how all of these kind of things. And then we started to work on, back then I was using this microcontroller called the Basic Stamp. Because of the cost of importing these things from the US to Italy, the cost would go up very much. So a small microcontroller, which was essentially a PIC chip, was like $100.
Yeah.
Clearly, a student's not gonna, spend that to make multiple prototypes. So you lose the ability to prototype a lot.
Yes.
So I built a platform myself that was called Programma 2003. And then one of my students built this other project, this master thesis with me and another person called Casey Rees, who is a professor over there who worked on this programming language called processing, which is a language that designers and artists use to learn about programming.
Okay.
So we kind of infused the learning of that project that came out of MIT into programming hardware. And this thing called wiring came out. And then out of the work done around that project called wiring, me and a group of other people that became kind of the founders of Arduino implemented Arduino, reusing in a way the structure of the language that wiring had, but then we implemented it in a different way. So we used very small microcontrollers. We built boards that you could solder yourself. I guess it was one of the first times that somebody would explicitly say hardware is open source.
Yes. So open source, now the barrier to entry is so low, because if there's even just one function that maybe does not quite make sense yet, you can still find somebody who maybe has done this, unpack it, and implement it yourself.
Yeah, I mean, one of the things that we found is that there was so much great open source software that we could just use. So the work that we did was just to put a nice wrapper around it. That was basically the user experience. So in a way, being born in an interaction design school makes us very interested in the user experience. Normally, in the past, a lot of development environments were not very user-friendly because you, as a developer, were supposed to be a professional. So you were supposed to suffer a little bit,
Pay your dues, and then you will.
Oh yeah, and I don't know. When I went to university, there was this idea that you would suffer as a, but the suffering would give you this degree that would make everything magical. Your life was okay, done, figured out.
You've given us enough of your blood And now
Yeah,
you are absolved of.
exactly.
How does this initial sort of inspiration that you saw in the classroom and solving that problem, how does this become what we now know today as Arduino?
So Arduino at the beginning started off as a tool to teach my students. Then one of my co-founders, Tomago, who teaches at NYU in a similar program to what we had in Ivrea, brought Arduino to the US and started to use it to teach to his students. And the combination of the way the thing was all set up, although it was kind of rudimentary back then, resonated with the students. He had a much larger pool of students, obviously in a much more prominent location in the world. And so the project that the students did generated also comments from people saying, hey, how did you build that? Oh, I use this thing called Arduino. And then it was very important if you build a platform, in my opinion, to try to target a kind of user who is creative, because they would create great projects. And then people will start to ask, oh, so what did you use to make that great project? And that will kind of feed back to you.
Yes.
Uh,
And it's growing your open source community. It's
yeah, making everything open source helped people jump in and kind of contribute and help and all of that. And then I guess at some point we realized that just providing the files for the PCBs, or maybe just even just the PCBs, was not enough. That people wanted to just buy the board already assembled. And that's how kind of Arduino as a company started back in those days. Because I noticed, and this is probably an interesting realization after all these years, that there are broadly, two big categories of people. There are people who are interested in using a tool to build something, and there are people who like to play with tools.
Yeah.
So in a way, there are some people that are interested in the inner workings of like a platform like Arduino. They have big debates on the way you implement the function, and they have big debates about all this. But they don't really build anything. They only build kind of demos of the code, whatever the hardware they're doing. And then there is a big category of people, which is the one that in a way Arduino resonated with and continues to resonate, is the people who don't care if the language is Python or C++ or it's Lisp. They don't care. They say, how can I build this thing that I have in my mind faster? Is this thing called C++? Okay, I'll do this.
Maybe you were originally successful and resonating with the category of people who want to use it and they don't care if it's Python, C++, whatever. Now you've certainly resonated with the people who are also now creating the tools. But at first, when Arduino was starting to pick up this momentum after it was brought to NYU and now it's in Europe and it's in North America, was there pushback? Was there a negative perception from the people who were shedding their blood at universities and saying you have to suffer for what you create?
Yeah, there was kind of some funny stuff going on because, there's a lot of people that did this job professionally. And obviously, when they looked at Arduino, they said, what the hell is this thing?
Really?
Because obviously, it was designed with a philosophy that's different.
Yeah.
A lot of people, in a way, at the beginning, they were saying things, oh, but no, you should just go buy the microcontroller itself and just program it in assembly language. There's no reason to, But it's understandable because the education system as a way to kind of screw with people a little bit, because people learn in a certain way. And when they become professor, they teach that to their students, and their students kind of pick that up. And some people just repeat the same pattern for years and years and years. So if you are told that a certain way of doing things is the way to do things, you're not really open to look at different aspects.
Correct.
I realized that a lot of people said, no, this is the right way to do things. And I was always fascinated by the people who use the word right and wrong. If one thing that technology tells us is that there's no really a right or wrong way to do things, there are multiple answers to the same questions.
Mm-hmm.
I guess a number of people didn't realize that not all the projects that you build are, I don't know, a dialysis machine where there is a patient attached with tubes, and if you make a mistake, everybody dies, no?
Right.
So if you take all the projects that you can build with microcontrollers and you kind of cut the curve at some point, there is a beautiful amount of projects that you can do with something that's less sophisticated but more approachable to people. And I guess that's the philosophy. So I guess a number of years in the history of Arduino were dedicated to make the whole programming process of microcontroller super simple, super easy, document it, engage with the community, use open source as a catalyst to get people involved. People buy in because they say, it's open source. If you decide to do something else in life, I'm just going to take the code and still stays with me,
Hey, it's Dave again. This segment of Moore's Lobby is sponsored by ST Microelectronics. Friends of the Moore's Lobby podcast know that electronic circuits form a mostly invisible part of the world we live in. These circuits are present in the chips that combine the latest advances in performance, intelligence, and efficiency. Hundreds or thousands of these chips are integrated into each of the millions and billions of electronic devices people across the globe interact with every day. In this unseen realm, ST Microelectronics creates the sparks that animate the products everyone uses all the time. ST's technology is found everywhere microelectronics makes a positive contribution to people's lives. Chips from ST are an essential part of products as diverse as cars and key fobs, giant factory machines, data center power supplies, washing machines, hard disks, smartphones, and toothbrushes. Because ST helps its customers make these devices more intelligent, more energy efficient, more connected, safer, and more secure. For more info, go to www.st.com. All right, I'm here in the lobby with Massimo Banzi, co-founder of Arduino. It doesn't seem as though there are any smooth roads to success, which is why a story like Arduino feels so rich and rewarding. You've got a community of users that is growing very rapidly. I remember the first time I heard Arduino one time, and then that's all I heard about for months and a couple years was, so it became very popular. You've also got a faction of maybe what I would call hardcore design engineers who at one point you had somebody online referring to this as baby talk for potheads.
Yeah, the Arduino language was described that, like that, which is fine. The world is full of grumpy engineers, and
But they can use that language. They can say these things. They can resist and oppose and say, "Oh, you have to suffer." The reality is, you cannot go to any major semiconductor manufacturer today and find evaluation kits of theirs that do not have Arduino Uno and R3 headers.
I know, I like that. It pisses off a lot of people.
I love that it pisses off people because I have seen companies like Medtronic or GE Industrial, some of the biggest companies out there, have come and said, we could spend the next 18 months starting from scratch on a 32-bit microcontroller or an 8-bit microcontroller and really build a proof of concept very slowly, or we could prove the concept quickly and have a lot more interactive design or iterative sort of prototyping going on if we use this card that gets us 70% of the way to our final product, 80% of the way there. And then we can focus on what we do best, which is customizing the application for our customers. This is why you see these R3 headers on every development board in the industry.
Yeah, no, I'm super. I am impressed at what happened. There. I guess there were some key things that happened at some point when Arduino was born. There was also the the maker movement was starting. No? So in a way, that when Arduino jumped out of the sort of design school world and went into the maker world, clearly that got a big acceleration. A bunch of people started to use it to learn. A bunch of people started to use it to build projects. They would go to maker fairs, they would go to blogs, they would go to different places, but also people inside companies started to build prototypes. And one of the things that happened, and I spoke to a number of people who did this, is that people who designed products, even imagine white goods, they were stuck in this process. They would have to write a very detailed specification and then throw it over the wall. And the engineers would build something and then they would send them back essentially a circuit. So the process for them was so frustrating because it was so rigid. So with Arduino, they could kind of prototype some ideas, some solutions. I know people who have worked at Apple and used Arduino to prototype things.
Yes, exactly.
And a job. I remember there was this job offer from Apple when they said, experience with Arduino is nice to have. So I was like, wow, we made it. This process enabled this more iterative process of designing some products that enable people. Or I've seen a lot of people that had no background in electronics. They started to do things with Arduino, and they ended up making companies.
Of course. So speaking of people who get hung up on the purity of their art or their science, how seriously do people take quote unquote makers and the maker movement?
I think I don't know if you're familiar. I guess you're familiar with the Gartner curve that describes how a technology goes through like a hype cycle, then it crashes down, and then it starts to become in a way useful. I think makers have gone through this hype cycle. There was a time where like every big company was sponsoring things that had to do with makers because they thought that they would magically receive all these amazing ideas back that they could, they would just, do like this massive innovation for them. And obviously these things don't happen like that. We went through a phase where people were kind of, disappointed, disillusioned in a way with the potential of makers. Makers continue to do their own thing; they don't care. But there's big companies that kind of are disillusioned by this. And obviously, what happened is that there is always some kind of criticism because of this expectation that wasn't correct. But we've seen a lot of stories of people that went from being a maker to build a company to do something. It amazed me, for example, a few years ago when I started to see Arduino used in industrial environments. And I met this company in Italy who works for all the car manufacturers. And they basically, one day they said, okay, this world of using these expensive PLCs for doing simple things is probably it doesn't make sense any longer. So they basically moved to Arduino. They grabbed a bunch of young people. Because one of the nice things about Arduino now is that a lot of high schools, a lot of universities are using Arduino to introduce people to technology.
Yes.
So you can literally open the door and just grab a person from the street. Yeah. And a lot of these people, yes, they know Arduino at different proficiency levels. This guy basically redesigned his company based on using Arduino as the controller. Young people, they grabbed from university or even high school, and they build specialized machinery that a car manufacturer used in the factory to automate different processes. So we helped with the microcontrollers. Then we started to help with connected products, and we built a bunch of connected products. And now we realize that the industry is asking for this type of product. And it's interesting to see how these companies are using the product to build things that you would normally build with either a very sophisticated computer or a very expensive PLC.
When you start seeing your technology, your product being used in a way that you hadn't originally intended, but it's being used just as fluidly and just as easily as your first initial 50 students in your classroom were using it, this has to be very exciting.
Oh yeah, it's amazing. Over the years, I received emails from people that used Arduino to do all sorts of things, and even a few times I even cried, because there were once I got an email from someone that was a disabled person. They used Arduino to kind of improve their life through Arduino. Obviously, that thing really touched me.
Yeah.
There's a lot of these stories, but for some strange reason, there is always kind of a place in my heart for factories. I love factories that make things because my uncle has a factory that makes certain products. And so when I was a teenager, I would go there as a couple of summers I worked there. My grandmother was building transformers, winding the transformers. So I learned how to build transformers when I was a kid.
Ah,
So in a way, for me, the factory is a super exciting environment. So the idea that you can see the stuff that I do that is used to create these solutions that kind of fall in this space that it's not covered by these classic, in a way, solutions, classic products.
mhm.
For me, it's very exciting because you can see the innovation coming from the people who work in the factory, the people who work in smaller companies, or even bigger companies are realizing that if a technology is based on Arduino, is now got to the point that it's a sophistication level that they can actually use it to their advantage, even in industrial setting. And I think that to me is super satisfying to go from kids are learning to build robots, then they go to school, they use Arduino, then they go to university, they again use Arduino. And then, I've met people. Once I was having a meeting at Bosch, and there was a product manager for a special sensor product. And this guy said, I want to thank you because I learned Arduino when I was in university. That got really excited about all this. And then I studied and I ended up here because Arduino. So when you hear this story, you're like, okay, my job is done. I'm okay. I'm good.
Where do we go next with Arduino now that you're seeing it being used not just as an educational tool, not just used as a prototyping tool? Where do we go now? Are you starting to turn Arduino towards very commercial purposes?
Well, I guess there are some directions. We started to develop a bunch of cloud platforms. So we have this IoT cloud that people can use just very quickly, create an object that connects to the cloud and you can control it from anywhere in the world. We also built this product that we call the Arduino Portenta, which is like the latest Arduino. And that's like a super powerful Cortex M4 plus Cortex M7 processor from ST Microelectronics
Yep.
that has like a bunch of memory, USB-C. It's designed and built to industrial standards, industrial temperatures. It's got an insane amount of pins that are available on a very high density connector, so you can just snap this thing onto products. And I think that's going to be important because this becomes essentially a little ingredient that you can connect to things and then you can enable your products with a real-time operating system. Yes, you're programming with Arduino statements, but you're sitting on top of EmbeddOS from ARM. So you have a real-time operating system, you have a dual core thing. So now we started to run, for example, machine learning tasks. So one of my kind of interests now is, can we make machine learning AI something that you can actually explain to people? Because right now, a lot of the tutorials, they say, oh yeah, we'll teach you this in 7 days. And the first page is a massive formula, no? So everything kind of gets explained in a mathematical fashion, but they are algorithms. So they could be taught in a different way. No? So for example, we are running different kind of tiny machine learning on this Portenta. We do computer vision on the Portenta. So we run TensorFlow. So we did a partnership with Google. So you can run TensorFlow. So again, one of these companies we work with is running this algorithm in this Portenta with a camera that has a little robotic arm that moves around the parts of a car and makes sure that certain elements are mounted before it goes to the next stage of assembly. Because if those things are not mounted, when they try to put it together, it just doesn't. So they basically check that the people are doing the correct work, and they're running the algorithm inside the device, so they can run it. It's a little box just attached next to the, let's say, hand, let's put it, of the robotic arm. And to me, that was very cool because these people, they built this, they don't have machine learning experience. So following the tutorials with this device, they built this computer vision thing that can be moved around a car looking for, did they put the right bolts in the right place? It was a very nice example of how you can enable people that normally would never think about doing, machine learning.
Yes.
Because you can give them the tools, you give them the tutorials, you give them. So you will see more and more tools going in that direction. And the other direction is also precision agriculture that we are very interested in. At the moment, at the border between the north of Italy and Switzerland, there is a problem because there is this insect that I could never pronounce the name because it's a long Latin word. But when that insect shows up, unless you intervene very quickly, you lose crop.
Yeah.
And over here, there is very specialized winemaking where there's not a lot of land dedicated to that, so they have to protect it. So they're thinking about using this low power, battery powered machine learning to basically trap these insects, see if one of those insects is in the trap, and then through LoRa alert the farmer that they have to come in and deal with it.
This is perfect. So now instead of applying pesticides across a bunch of acres that you don't need pesticides, you can be very targeted in your treatment.
Because especially if you're doing organic farming, you don't want to just throw chemicals left and right. Another example of another parasite of vineyards shows up specifically when the temperature and the humidity go through a certain curve. So essentially, with a temperature sensor and a humidity sensor and a little algorithm, you can basically say, in this part of the vineyard, we went through this cycle, this particular parasite will show up. So you can come in and...
Yes. And now with technologies like LoRaWAN and other low power, and like you said, GSM, it's very viable now. It's very practical.
Yeah, for example, over here in Switzerland, where I live, the whole country is covered with the LoRa network.
The whole country?
So the whole country. Swisscom, the operator here, has a geographic LoRa. So basically, almost anywhere in the country, you can turn on. There's a specific board called Arduino MKR 1310. We used it to do a number of projects. And you turn it on, and you are connected.
Massimo, you've created something for which people will be thanking you generations from now. Not too many of us can say that about our work. Here you were a young boy, you see a computer in a shop window and you say, Dad, if I buy this, I can help you do this. And your dad says, okay, so we'll buy it and put down the money.
Yeah.
Is it fun for you to tell him like, well, now the Arduino, the thing that I was building is now being used is factory automation and it's being used in...
Yeah. I have been told by people that met him that he brags.
Very proud father.
In a way, yeah.
This is a good feeling.
Yeah, no, it's funny. It's like, for example, once I was on the cover of Wired magazine in Italy. So my mother went to the newsagent to buy it. And obviously she was like, or my hometown, Monza, the local newspaper, one year made me like Monzese of the year. So I was so my mother was like, hey, I'm just buying 3-4 copies of this because this is... So it's very nice because at some point, at the end of the day, I don't know. I guess it's nice to see this.
Of course. Okay, so next time I visit Monza, I'll have to ask about the local celebrity Massimo Banzi. Maybe I used to stay at the Hotel Royal Falcone, so maybe they could give me free hotel rooms.
I'm not that famous, but
Thank you so much for coming on and sharing all this wisdom with us.
oh,
This is.
yeah, now I'm spending a little bit of time advising startups whenever I get the chance.
Oh, really?
Also because well, yeah, occasionally, because it's funny because I keep saying to them that all the mistakes I made are now are now available to you. I think if you're an entrepreneur, you should try to build businesses that go on, that continue in time. Designing companies so that you can just sell them, it's less appealing to me. And the other thing, I think that you should, we give back a ton by being open source and being super open and giving away all the work that we do. But there's also a little bit of, giving away also something about your personal experience to somebody who is younger. And if you can save them a little bit of pain, it's kind of nice.
It is what a it's a fantastic legacy that not too many people get to enjoy. What are three obvious mistakes that you made when you were starting Arduino, where you look back now and say, "Oh,
Yeah, I mean, in a way, I think people should understand that sometimes you have an idea and you do it just because it's fun, but at some point that idea might become some kind of a company.
yeah,
So there will be business around that. So if you don't set it up correctly at the beginning, because a few years ago we had this big problem with one of the former, say, founders of Arduino, that we had like a long lawsuit.
yes,
And because we didn't set it up properly. And then since it was just, we thought we were just a bunch of friends, then obviously some people believe like that. And some people think, well, yeah, but now that it's.
yeah, yeah,
So obviously, imagine always clarify who owns what, who is in charge of what, and that kind of stuff. That's for sure something that you have to keep in mind. Also, because in a way, when you pick co-founders for your project, it's like a marriage. You are with them for as long as So
yeah."
I mean, there's so many things. There should be a different
A whole episode.
a different episode of the podcast just for that.
Do you see yourself writing a book?
I don't know. I don't know if I want to do that. The pain of the long lawsuit is still with me, so I'm not.
That has to be very difficult because, like you said, you think you're going into something being friends, and the other people start acting in a way that's the opposite of friendship, the opposite of what you expected. But it's also professionally, it's situations like that can be very draining because it
Yeah.
zaps your momentum. It takes your focus off what you started the company to do, maybe.
Yeah, it's one of those things that how can I say? It's well, there's a long time where you think you know somebody, and then you realize that there are some things that over the years people grow and they take different directions. So the people that you might know before are different over the years, and I guess the way they perceive themselves inside something changes. And so I guess that's if you don't have a way to kind of keep, I don't know, to keep the communication flowing. Sometimes there are and then during the lawsuit itself, it's hell. It's really bad because then obviously both parties use anything they have to attack the other. And so I remember I woke up one morning and somebody called me on the phone, and there was an article on the newspaper saying that I have left Arduino to do something else.
What?
And this because, well, somebody from the other side made a press release
Yeah.
saying that now they were the CEO of Arduino, and I went doing like non-profit work,
Wow.
And a bunch of journalists just pick up the press release and published it. And I spent the rest of the day on the phone saying, "What the hell did you just write?" And but I had to, and so a number of times I woke up in the morning or during the day, there was an article about me online that was, clearly not true, but it was.
It's hurtful. It's hurtful to read these things.
It's part of the normal. But anyway.
Do you think there's any chance at reconciliation personally now that the lawsuit is over? Maybe not even worth it.
I don't know. I mean, it's what's there to,
Yeah. That was so painful for so long. What do we have left?
It's complicated. It's complicated.
Understandable. It's one thing that I've noticed is that very, very difficult situations like that are even harder for me because I think like an engineer. I always think about fair and just. So is there justice? Is this fair? Why is this happening? And if I can't reconcile for myself why something is happening and it feels just unfair and unresolvable, that bothers me probably more than anything else.
Yeah, but human beings have a very good way to justify to themselves whatever behavior they have in a certain moment.
Yeah.
I guess as a human being, if you do something because you're driven by something, then you need to reconcile that, say, oh, but I'm justified because,
This is true.
So people are really good at justifying to themselves why they are behaving in a certain way.
This is true. This is why I'm glad my wife does not let me justify my bad behaviors.
Yeah.
I feel like I want to go spend 3 months living next to you and writing a documentary about your life.
But as soon as this pandemic is less of a problem, come over to Switzerland.
I would love to.
The warm part of Switzerland.
Oh, so. Are you by Lake Como?
Lugano. Yeah, it's just north of Lake Como.
Oh, you, sir, have won life. If life is a contest, you won.
I'm not sure.
All right, big thanks to Massimo Banzi for making time to chat with me today. Be sure to subscribe to Moore's Lobby on any of the major podcast platforms, including Apple, Spotify, and Google Podcasts, to enjoy new episodes every 2 weeks with industry experts from world-renowned companies who join us to chat about leading-edge technology and engineering topics. You can also follow us and catch prior episodes on allaboutscircuits.com. Thanks for listening.